Here's an example of the prototype for a reverse spring tension for the Legolas apparatus. You can see in this case the force is very low when it's all the way forward. As it grabs the string, the force actually increases as it's coming back and is fully capable of pulling the bowstring all the way back. The problem is a bow has a force diagram that looks like this. As you draw the bow further back, and the force will then increase with a line that looks about like this. Now if we try to counteract that force, the issue is if you use a regular rubber band or some other, even a bow element, you're going to have the same issue with a force line that looks about the same. The issue is we want to have something that reacts as a negative spring constant, where with very little draw we have high force, and as the draw increases, the force actually decreases. So this is the mechanism that we came up with that would help to make the Legolas device a viable device. Here we can see as we're moving forward, it takes a high amount of force to move the Legolas device forward, and then slowly backs off to the point where it goes to zero and actually requires no force to stay in the final resting position. At this point, the bowstring would be attached to the device, and with a very minimal amount of force to get it going by pulling back on the apparatus, it will slowly start kicking back into fully extending the bowstring to its maximum value. Let's take a closer look at the mechanism that's being used. In this case, we have a rubber band that's acting as the tension element. That tension element could also be a string connected to a metal spring or a wooden bow element in medieval times. The secret to the mechanism's function in creating a negative spring force is by having the element under quite a bit of tension and rotating it around a radius. Thereby, as the mechanism moves forward, we go from a high tension state into a low tension state, and finally into a state where it's stable with zero tension on the sliding mechanism. At this point, you would connect to the bowstring, and as you pull it back off of that metastable position, the forces will then cancel each other out and automatically pull the bowstring all the way back. Here is the medieval version where we've replaced the rubber element with a tension spring made out of wood. You can see that it still is a functional bow, and the apparatus will still function as intended earlier, where it will completely draw the bow without any problem.